Download this code from codegive.com, link in the description below. OK, let's dive into the world of Keras callbacks. This guide will provide a comprehensive overview of what Keras callbacks are, why they're important, how to use them effectively, and how to create your own custom callbacks. We'll include code examples throughout to illustrate these concepts. What are Keras callbacks? Keras callbacks are powerful tools that allow you to gain fine-grained control over the training process of your Keras models. They are functions that are automatically called at certain stages of the training loop, example at the start or end of an epoch, before or after a batch. This allows you to monitor training, track metrics like loss, accuracy, or any other custom metric. Early stopping, halt training when the model's performance stops improving on a validation set. Model checkpointing, save the best model weights during training. Learning rate scheduling, adjust the learning rate dynamically based on training progress. Custom actions, perform any other custom actions you need during training, such as logging, visualizing, or sending notifications. Why are callbacks important? Improved efficiency, callbacks prevent wasting resources by stopping training when it's clear that further epochs won't yield significant improvements. Better model performance, learning rate scheduling and checkpointing can lead to better generalization and higher accuracy. Enhanced monitoring, callbacks provide visibility into the training process, allowing you to identify potential problems early on. Flexibility and customization, you can tailor the training process to your specific needs by writing custom callbacks. Built-in Keras callbacks. Keras offers several built-in callbacks that cover the most common use cases. Let's explore some of the most useful ones. 1. Model checkpoint purpose saves the model or its weights at regular intervals during training. Crucial for saving the best performing model. Parameters file path, the path to save the model file, example best_model.h5, weights epoch 02d-val_loss.2f.h5. The epoch and val_loss placeholders will be replaced with the current epoch number and validation loss, respectively. This is excellent for versioning. Monitor, the metric to monitor, example val_loss, val_accuracy. The callback will save the model when the monitored metric reaches a new best value. Verbose, 0, silent, or 1, show messages when the model is saved. Save_best_only, true to save only the best model based on the monitored metric, false to save at every epoch. Save_weights_only, true to save only the weights of the model, false to save the entire model, architecture plus weights. Saving only the weights is generally more space efficient. Mode, auto, min, or max. Defines whether to minimize or maximize the monitored metric. Auto infers the mode from the metric name, example val_loss implies min, val_accuracy implies max. Period, interval, number of epochs, between checkpoints. Example In this example, the model checkpoint callback saves the model with the lowest validation loss to best_model.h5. The save_best_only equals true ensures that only the model with the best performance on the validation set is saved. The model is reloaded after training to evaluate the best version. 2. Early stopping purpose stops training when a monitored metric has stopped improving for a certain number of epochs. Prevents overfitting and saves time. Parameters monitor, the metric to monitor, example val_loss, val_accuracy. Asterisk patience, the number of epochs with no improvement after which training will be stopped. A larger patience value allows for more minor fluctuations. Asterisk verbose, 0, silent, or 1, show messages when training is stopped. Asterisk mode, auto, min, or max. Defines whether to minimize or maximize the monitored metric. Asterisk restore_best_weights, true to restore the model weights from the epoch with the best value of the monitored quantity. This is extremely useful, as the model at the last epoch before stopping might not be the best one. Asterisk example asterisk. The early stopping callback monitors the validation loss, val_loss. If the validation loss doesn't improve for 3 epochs, patience equals 3, training is stopped. Restore_best_weights equals true ensures the model is reset to the weights it had when the validation loss was at its lowest. The history object returned by model.fit contains a record of the training and validation loss and metrics for each epoch. You can use this to visualize the training process and confirm the early stopping behavior. 3. Reduce LR on plateau asterisk. Asterisk purpose asterisk reduces the learning rate when a metric has stopped improving. Can help the model escape local minima and converge to a better solution. Asterisk parameters asterisk. Asterisk monitor, the metric to monitor, example val_loss, val_accuracy. Asterisk factor, the factor by which the learning rate will be reduced. New_LR equals LR asterisk factor. Asterisk patience, the number of epochs with no improvement after which the learning rate will be reduced. Asterisk verbose, 0, silent, or 1, show messages when the learning rate is reduced. Asterisk mode, auto, min, or max. Asterisk min_LR, a lower bound on the learning rate. The learning rate will never be reduced below this value. Asterisk example asterisk. In this example, if the validation loss doesn't improve for 2 epochs, the learning rate is reduced by a factor of 0.5. The learning rate will never be reduced below 0.00001. History LR allows access to the learning rates during training. 4. TensorBoard asterisk. Asterisk purpose asterisk logs data for visualization in TensorBoard. Allows you to monitor metrics, visualize the model graph, and inspect the weights and biases. Asterisk parameters asterisk. Asterisk log_dir, the directory where the logs will be stored. Asterisk histogram_frequency, frequency, in epochs, at which to compute activation and weight histograms for the layers of the model. If set to 0, histograms won't be computed. Validated against validation_data or validation_split if provided. Asterisk write_graph, whether to visualize the graph in TensorBoard. Defaults to true. Asterisk write_images, whether to write model weights as images to visualize in TensorBoard. Asterisk update_frequency, batch or epoch or integer. When using batch, writes the losses and metrics to TensorBoard after each batch. The same applies for epoch. If using an integer, let's say 1000, the callback will write the metrics and losses to TensorBoard every 1000 samples seen by the model. Asterisk profile_batch, by default, profiling is disabled to avoid overhead. Set this to an integer to profile the specified batch, or pass a tuple of integers to profile a range of batches. Asterisk embeddings_frequency, frequency, in epochs, at which embedding visualizations will be written. Asterisk example asterisk. This example logs data to the logs/fit directory. To view the logs, Run TensorBoard logdir logs in a terminal and open a web browser to http://localhost 6006. You will then see interactive visualizations of your training process. Using multiple callbacks. You can use multiple callbacks together during training. Just pass them as a list to the callbacks argument of model.fit. In this case, model checkpoint, early stopping, and reduce LR on plateau will all be active during training. Creating custom callbacks. The real power of Keras callbacks comes from the ability to define your own custom callbacks. To create a custom callback, you need to create a class that inherits from keras.callbacks.callback. You can then override the methods that correspond to the events you want to handle. *on_train_begin, self, logs equals none, called at the beginning of training. *on_train_end, self, logs equals none, called at the end of training. *on_epoch_begin, self, epoch, logs equals none, called at the beginning of each epoch. *on_epoch_end, self, epoch, logs equals none, called at the end of each epoch. *on_batch_begin, self, batch, logs equals none, called at the beginning of each batch. *on_batch_end, self, batch, logs equals none, called at the end of each batch. *on_test_begin, self, logs equals none, called at the beginning of testing. *on_test_end, self, logs equals none, called at the end of testing. *on_predict_begin, self, logs equals none, called at the beginning of prediction. *on_predict_end, self, logs equals none, called at the end of prediction. The logs dictionary contains information about the current state of the training process, such as loss and metrics. You can access this information to perform custom actions. Example, custom callback to print metrics at the end of each epoch. This custom callback print epoch metrics prints the training loss, training mean absolute error, may, validation loss, and validation may at the end of each epoch. Notice how we access the metrics from the logs dictionary using logs.get. Example, custom callback for logging to a file. This callback file logger appends training metrics to a text file, training_log.txt, at the end of each epoch. This provides a persistent record of the training progress. Important considerations. *monitor relevant metrics * choose the correct metric to monitor for early stopping, model checkpointing, and learning rate scheduling. The choice depends on your specific task and goals. For example, val_loss is often suitable for regression tasks, while val_accuracy is more appropriate for classification. *tune patience and factor * the patience parameter in early stopping and reduce LR on plateau and the factor parameter in reduce LR on plateau need to be tuned carefully. Too small a patience value can lead to premature stopping or learning rate reduction. Too large a patience value can waste resources. The factor should be tuned to the problem. A smaller factor means more gradual learning rate reductions. *use restore_best_weights * when using early stopping, set restore_best_weights equals true to ensure that the model is reset to its best performing state. *handle nan values * be aware that training can sometimes produce nan, not a number, values in the loss or gradients. This can be caused by numerical instability or exploding gradients. You can use a custom callback to detect and handle nan values, such as by reducing the learning rate or stopping training. Asterisk TensorBoard for debugging. Asterisk use TensorBoard to visualize the training process and debug any issues. You can monitor metrics, gradients, weights, and the model graph. Asterisk callback order. Asterisk in some cases, the order of callbacks in the callbacks list can matter. For example, if you have both an early stopping callback and a model checkpoint callback, it's generally recommended to place the model checkpoint callback first, so that the best model is saved before training is stopped. Advanced techniques. Asterisk combining callbacks. Asterisk you can combine multiple callbacks to achieve complex training strategies. For instance, you can use model checkpoint to save the best model, early stopping to prevent overfitting, and reduce LR on plateau to fine-tune the learning rate. Asterisk custom metrics. Asterisk you can define custom metrics and log them using callbacks. This allows you to track specific aspects of your model's performance that are relevant to your task. Asterisk experiment tracking. Asterisk integrate callbacks with experiment tracking tools like MLflow or weights and biases to automatically log training metrics, hyperparameters, and model artifacts. Keras callbacks are a powerful tool that can significantly improve the training process of your machine learning models. By using the built-in callbacks and creating custom callbacks, you can fine-tune the training process to your specific needs and achieve better model performance. Remember to experiment with different callback configurations and monitor your training progress to find the optimal settings for your task.